This video explains the use of non-parametric tests to assess the influence of categorical variables on other categorical variables. The chi-square test of independence is the main tool, but there are others we'll touch upon. The key deciding factor to use any of these non-parametric tests is that the dependent variable can only be measured as a category. For example, if your independent variable is age and your dependent variable is did you vote, the age needs to be collapsed into categories to run the non-parametric test. As long as your dependent variable can possibly be framed as a continuous measure, then you may not need to use chi-square at all. Contingency tables, also known in SPSS as crosstabs, are what you use to display your independent and dependent variables as cells in rows and columns. Expected frequencies, assuming the null hypothesis, are compared to observed frequencies to determine if the test value is large enough to reject the null, that is, claim the variables are linked, thus not independent. If any of the cells is 0, or if more than 1/5 of the expected frequencies are below 5, then use Fisher's exact test instead of Pearson chi-square if you have a 2x2 contingency table. If the variables are not independent, as would be the case in a before-after comparison, then use McNemar's test for 2 samples, or Cochran's Q for more than 2. For most simple studies of sufficient size, chi-square works just fine with a limited number of cells. Several options for effect sizes exist for chi-square. Crumer's V is more popular than Phi, which is only used for 2x2, because it handles larger tables. The one-sample chi-square test is rarely used, so let's focus on the test of independence. Suppose your independent variable is gender and the dependent variable is choosing to stream an action movie. If sex makes no difference, then we would expect equal proportions choosing and not choosing such a video. Women like action movies, but do men like them more? Here are a few cases that we can look at in SPSS. Choose the Analyze menu, then Descriptive Statistics, then Crosstabs. Assign sex as the row, and choose vid as the column. And if you're wondering why the odd names, at one time SPSS limited you to 8 characters, back when computers worried about memory storage. Click on Statistics and choose chi-square. Also choose Phi and Crumer's V. Lambda is for when you have more than 2 levels of a variable. Click Continue. Click on Cells and choose Observed and Expected and Row and Column. If you had more than 2x2 table, I would have recommended unstandardized residuals too, because that will tell you what cell is driving the result if there is one. Click Continue and OK. The results show that you have 74 comparisons. DF, degrees of freedom, is always 1 for a 2x2 table. It's calculated as number of rows minus 1 times the number of columns minus 1. Chi-square is 4.33. And it appears none of the assumptions are violated. P is less than 0.05, so men and women seem different with regard to action movies. The effect size is 0.24, where 0.1 is small, 0.3 is medium, and 0.5 is large for V if you're looking at a 2x2 table where DF equals 1. That's essentially what you need for comparisons of dependent categories. It matters more with measures like did you vote. In this example, the question of videos could have been reframed as how likely are you to stream an action video, and then a t-test could have detected mean differences in continuously measured likelihood between men and women. With past voting, however, you can only have a dichotomous outcome, and you need to use chi-square. That's all for now. See you next time.